Um, Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to give you another code review. This code review is on a linear regression, and so it's with college distances of students. So I thought that was very interesting. And we're using statsmodels as the linear regression estimator, and we're using the R dataset as the dataset. So it's very interesting, and we're using some different code techniques that we normally use, which is why I wanted to go ahead and do this code review for you. So the first thing we did was we got the dataset off of a repository in GitHub, and it contains datasets in R. And so this is the repository GitHub, I think. So this is the GitHub, and then on the top of the program, I give you the link that you can access. And I don't, obviously it should be big enough on your screen, so you can just copy the website address to get the link if you want it. And so we created our program in Google Colab. Google Colab is a free online Jupyter notebook hosted by Google. It's really good program. It's free, provided by Google. And I haven't found another program that performs as well as this does. I mean, Replit is another program that I don't use that much, but I don't even think Replit is as good as Google Colab, and the reason why is because it's hard to get the libraries in Replit. I've tried to use Replit on a few instances with other programs, and I couldn't do it because of the libraries, basically. The libraries wouldn't load up. So that's why I stick with Python, because I've got Google Colab, and I'm not aware of another interpreter, free online interpreter or compiler for another language. And so until I get another free compiler or interpreter for another language, I'm going to stick with Python. So after we created our program in Google Colab, and I will say the thing about Google Colab is it doesn't have a very good undo function, so you have to be really careful not to overwrite or delete valuable code. The only undo function that Google Colab has is, well, you can't see it here, but it says an undo, and you can't see it here, and it would be like an undo select cell. So you can go into Google Colab when you do something, and it will say undo select cell or redo. But if you really delete some code and you're upset about it, you can go back into your save history. And if you go back into your save history, there's a possibility that you might be able to get that code back. So I just thought I would show that to you. So now that you know about the good points and the bad points of Google Colab, what we'll do is we'll import our libraries. So we'll import pandas as a PD. And when I was importing pandas as PD, I got a message saying that there was a certain utility in pandas testing that was being deprecated, and then so you needed to use this utility here. So I went ahead and put that utility in there, although I'm not sure exactly if I'm going to be using it, but I thought, well, just to be on the safe side, since some of Pandas' work is being deprecated, I'll go ahead and put it in there. And then we'll put Pandas is a data processing library. It enables you to create and maintain data frames. And then we're going to import NumPy as NP, and that carries out numerical computations, and it also creates NumPy arrays. We're going to import math, which is an inbuilt library, and Python, which enables you to carry out like more complex mathematical operations. We're going to import statsmodels, which is a statistical library. And I was watching a 9-year-old video, and the 9-year-old video said that statsmodels had originally been part of SciPy until I guess it got so big that they decided to make it a library in its own right. But I started watching that 9-year-old video, but I had to stop it because statsmodels has changed a lot in 9 years, and I just feel that they should take that video down. It might be worthwhile for historical reasons, but it's not current. And even I watched videos that were like maybe made 3 years ago, and statsmodels has changed even in 3 years. And so because all of these libraries change, you have to keep abreast of all the changes going on in the libraries. So statsmodels, there's not really a lot written on it. There's not a lot on YouTube about it. So that's why I'm making these videos on statsmodels, just to get the code out there, because they don't even have a lot of example code in their documentation. They have some example code, but not a lot. And then after we've imported statsmodels, we'll import matplotlib pyplot splt, which is a graphics library, and it plots all of the data points onto a graph if you want to. And then we'll import Seaborn, which is another higher level graphics library written on the back of matplotlib, which enables you to do higher level graphics computations. We also may be importing sklearn at some point in this program, and sklearn is Python's machine learning library. And I will say that I like sklearn a lot. sklearn is a lot easier to use than statsmodels. The documentation on it, it's got lots of documentation, it's got lots of sample code. So I think that's why one of the reasons why people prefer sklearn to statsmodel, and I think that sklearn outperforms statsmodel in its estimators, but we'll go ahead and talk about that later. So after we've imported our libraries, what we're going to do is we're going to load the data set. We got the data set from the college distance website. We've got the data set from an R repository. And I already showed you the repository, and you have to use different code to get this data set than you do to get when you're using pandas. So data equals sm.datasets.get R dataset, college distance and AER, and then you print data.doc, and then when you print data.doc, you can see the documentation on the data set. It tells you a little bit about this data set. So it gives you gender, ethnicity, score, F college, M college, home, urban, unemployment, wages, distance from 4-year college in 10 miles. So it's a different distance from the 4-year college in 10 miles. And then so what we do is, because we want to be able to use this in Python, so data equals data.data. And then so I just guessed that. Nobody showed me that. I just was thinking, well, how do I get this to work? And I just did a swag. I don't know if anybody's ever heard of a swag. It's called scientific wild ass guess. So that's what I did. I did a swag to get it to work. And so you've got your gender, your ethnicity, score, F college, M college, that's father's college, mother's college, home, urban, unemployment, wage, distance, that's distance in 10 miles, it's not distance in miles, tuition, education, income, and region. So what I did was I made the label distance because it said college distances. So I was working on the assumption that the target was going to be distance. So that's what I did. Check for null values. There's no null values in that data set, so you don't have anything to impute. Checked for unique values. So that's really interesting. So if you want to know all of the unique values in the data set, you can do a for loop on the columns, and then unique values equals data column dot unique, and then it'll tell you what all the unique values are. So this says ethnicity, it says other, and I think African American is AFAM and Hispanic. So other may be white, I'm not sure, because African American. So what they want to do is they want to look at African American and Hispanic families. Oh, so maybe it's just for ethnics, who knows? The score, I think this is the score of base year composite test score. These are achievement tests given to high school seniors in the sample. So that's what they scored in their senior year in high school. F college, that's father's college, mother's college, home. Let's see what home stands for. Does the family own their home? So it asks you if the family owns their home. Urban is the school in an urban area? And unemployment rate, wage rate, and distance from school, and that distance is in 10 miles. So if it says 0.2, that means it's going to be 2 miles. Okay, so you can see all that. It says tuition. Let's just see. Yeah, so you got tuition, education, income, and region. So the tuition is tuition of an average 4-year college in thousands of dollars, education, number of years of education, income, that's a factor, region is a factor. So it gives you information on all of the columns in that data set. And you can see all the unique values. So what we're going to do is we're going to encode the features. And so basically what I did was every column that was an object column, I encoded it. What I would have done is if it was just like maybe one column with like a few categories, then I would have done it, used the replace function, but since it was quite a few columns with quite a few unique values, I decided to ordinal encode it just for simplicity's sake, and I used a for loop for call and data. If data call dot dtype equals object, data call equals inc fit transform data call dot values dot reshape -1 1. So what you have to use that to reshape the column to get it to work. And then we call up data, and you can see that all of the columns are numeric now, which is what the computer wants to see. So we've analyzed targets. So you can see the distance away from targets is, the distance away from college in the target, you can see that it starts out really high at 0, and then it peters out to actually 20. So 20 times 10 is 200 miles. So some of the people in this data set were traveling 200 miles to college, which means they may have been living close to the college for their college. So we've got our QQ plot. I'm not sure exactly what a QQ plot is. It's something to do with statistics. So we'll say, yes, we'll just say, what is QQ plot? And it says, when the quantiles of two variables are plotted against each other, then the plot obtained is known as a quantile-quantile plot, or QQ plot. This plot provides a summary of whether the distributions of two variables are similar or not with respect to the locations. So there's your QQ plot, and then we did it on the distance, and then we got it, yeah, we just did it on the distance, and so it was just checking the distance against other variables, I guess. But there's your QQ plot for statistics, and that was also in statsmodels. Statsmodels has a lot of statistical functions. Now what we're going to do is we're going to remove the outliers in an attempt to improve our accuracy. So I've got some code here that will enable us to remove our outliers, and we're going to be removing 268 lines of code out of 4739. So if you don't remove your outliers, then your accuracy may not be as good. So what we're doing is we're attempting to improve our accuracy by removing the outliers. And then so what we do is we drop all of the rows, because what they do is they take the rows that are outliers and they convert them to null values. And then when it's a null value, it comes up as a null value. And so what it's saying is drop all the rows that are null values. And so that's what it's done. And so it deletes 268 rows. So we do a disk plot on our target again, and you can see that you don't have as many outliers. So it's up to you whether you want to reduce the outliers. It may improve your accuracy, but it means that the highest distance that people are going to travel is going to be 60 miles instead of 200 miles. So you do, when you have an outlier, you do get rid of some of the data. So it's up to you whether or not you want to use it. Then what we do is we do a heat map, and what this heat map shows is his heat map shows how the columns correlate to each other. And then what we're going to do is we put some code in here to remove columns that have a high correlation. But none of the columns had a high correlation. So the code didn't do anything because none of the columns had a high correlation. But I kept the code in there so you can see the code. And then what I did was I shuffled the data set I use sklearn to shuffle the data set. There is a way that you can do it in pandas, but it's more difficult. It's got more code in it. And so sklearn has this little function called shuffle that you can use. And then I define our x and our y variables. Your y variable is the distance, and then you drop the distance from the data. And then when you drop the distance from the data, then x is the rest of the data. So you can see that you've got x here, and it's not got the distance in there anymore. And then what we do is we normalize the data, and what happens when we normalize the data is we take all of the values and we convert them to a value between 0 and 1. And the reason why we do that is because the model works better if the values are not really far away. You know, that's the best way that I can put it if it's not really far away. So now what we're going to do is we're going to split our data set. So the training set is going to be 90% and the testing set is going to be 10%. And then so we set up our X train and our Y train, and then we set up our shapes to make sure that we haven't made an error when we split our data sets into training and testing. And remember that we previously shuffled it. So now we're going to use stats models, and we're going to use ordinary least squares, and this is just a linear regression. And so we're using ordinary least squares, and then we print the summary, so you get a summary, and it tells you that the dependent variable is distance, your R squared is 0.577, your adjusted. It gives you some more information. The method is least squares, model is OLS, number of observation is 4023, DF residuals is 4010, DF model is 13. So let's see how many observations. 4023 is your observations, and then it gives you some more information. It gives you a coefficient, standard error, gives you your t-value, see if your p is greater than t, and then it gives you your 0.025 and 0.975. So the 0.025 and the 0.975, that is to do with statistics, whereas that's like your third standard deviation. So most of the data is going to be covered in the third standard deviation. Now we check out our params. I tried to look up to find out what params is on the internet because it didn't really give you a lot of information in stats models, but I think it's something to do with parameters. Now we check our model coefficient. Now what we do is we print the average of your X train, and so it tells you the average of each column in X train. Print the standard deviation of every column in X train. Now we print our YPRED. So YPRED equals model.predict xval, and so what YPRED does is it gives you a value between 0 and 1, because what it does is it predicts the probability that something will occur. And then what you have to do is you have to round it. So I rounded it to 2 digit points, decimal points. And then anything less than 0, I'm just going to make it a 0 because you're not going to be traveling negative distances. Not in this world anyway. Maybe in another reality you'll travel negative distances, but in this reality we don't travel negative distances. And then you check your YPRED. So your YPRED is, oh sorry, I made a mistake because we're working on linear regression. So you're not going to be getting the value between 0 and 1, but I just rounded it because I wanted to round it because I wanted to be similar to what the actual distance was, and that's why I rounded. So please forgive me, I made a mistake. I was thinking about another type of estimator. So now we check our error. So your MSE is 1.6 and your RMSE is 1.2. So that's a pretty good error. And now we check our YPRED. Check our YPRED again, which we'd already done that once, so we don't need to do it again. So I'm just going to delete that. Okay, and then now what I've done is I made my own code. So what I was doing is I was checking, comparing the values. So if you're made a for loop, which is the length of xval, so if YPRED values I is the same as YVal values I, then correct pred equals correct pred plus 1, else correct pred equals correct pred plus 0, and score equals correct pred over length of val. So we had a very low accuracy a very low accuracy. So when you're dealing with linear regression, you deal with the error anyway, and so you want to get the smallest error possible. So we had an RMSE of 1.266. That was our error. And then so we've got a data frame, and the data frame tells you where you can compare the actual value against the predicted value. And then we've got the, we plotted it on a graph so you can see what it looks like on a graph. So it didn't do that well, did it? So then because it didn't turn out that well, so I wanted to compare it against sklearn to see how sklearn performs. So we're using sklearn linear regression, and we got a 186% accuracy when we trained and fitted the model, and when we predicted on the validation set, we got a 0.151. So right away, our accuracy is better with linear regression than it is it's better with linear regression on sklearn than it is on statsmodels. So you can check your YPRED here. This tells you all your YPREDs. And we want to check our error. So your MSE is 1.53 and your RMSE is 1.24. So we're going to go back here to statsmodels and look at our error. So statsmodels had an MSE of 1.6 and RMSE of 1.266. So right away our error in sklearn is less than it is in statsmodels. So we've got a data frame where you can compare your actual values against your predicted values. And then we plotted on a graph. So it didn't really turn out that well with both of them, but I will say that the error on sklearn is slightly less than the error in statsmodels, and that's probably why people want to use sklearn more than they want to use statsmodels, because sklearn tends to outperform statsmodels, but statsmodels has a lot of really good other functions in it because it does time series and statistics and things like that. But I just wanted to show this to you as an example of how to use statsmodels with linear regression, even though sklearn outperforms statsmodels. So I'm going to go ahead and conclude this video because I've been talking for almost half an hour. So I want to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you so much for watching this video, and I look forward to making more videos for you in the future.